Let's continue with the theory for this seminar. Can everybody listen here now? We are going to talk about Git and DCVS. Let's see. Do you remember the shortcut for full screen on a Mac? Anybody with a Mac here? I always forget it. Yeah, but it doesn't matter.
Probably F11.
Yeah, I think so. No. Function F11? No. Let's move on. It doesn't matter. DCVS and Git. What do you know about Git or Git?
That it's a source control tool.
Source control tool. Yeah, that's correct. Let's look a little bit into it then. We typically call it version control system, and if we put a D in front of it, we have a distributed version control system. So typically, Git is classified as a DCVS, and former version control systems, as for example Subversion, that was a VCS, not distributed. So we'll look into the differences there. And SCM is also called Source Control Management. So we'll look into VCS terminology, Git and Git flow, and distributed Git services. So remember that this will be quite basic, because I want everybody to be up and running on the version control management and so on. So probably if you have used Git a lot, you won't find this very informative. So I just warn you now. But I will give you some tips that will be quite maybe new for every one of you, and that's about branching and branching modes, because there are different types or techniques to set up your branching modes. So I will encourage you to stay put and listen anyhow. So Git basics, Git flow. Have you ever heard about that? Yeah. So have you used it? No. Git flow basics and Git and version control workflows. So what is version control? Code changes because you have bug fixes, you have new releases, new features that you want to implement, and so on. So you would like to manage the entire history of your repo or your code. Mistakes are made, and developers often need to track back. So what you can do with a version control management system or a VCS is that you can track back to changes that you have made. Maybe you introduced a bug in your code, and you have, but you know that you have earlier versions of your code, so you can track back to that version. And that's the whole idea here, is that you can track back. So what is a version control system? DCVS, that's a distributed version control system, and you often find the terminology SCM used as well. That's source control management. Both terms closely related to revision control in software engineering. Distributed VCS. These VCSs do not rely on centralized servers. Local repositories contain all revision data. So if you set up a Git repo, for example, on your computer, you will all have the entire revision history there. And that goes for if you clone a repo. I will come back to what cloning is. If you clone a repo from a distributed source or a server, a Git server of some kind, then you also have the entire revision history on your machine in your Git repo. So we call it cloning when we more or less bring a repo down from a server, a Git server, and copy it down to our machine. Do you know any other version control systems than Git?
Yeah.
Other distributed?
I have PS and Git like this.
Sorry?
Git like this. That's a Git system.
That's a Git. You're using Git there. It's a Git server. Yeah, because you have also another alternative that's Mercurial. You can look up that if you want. But Git is very popular. It's more or less a branching, or in an industry standard, you can say, a de facto standard. And it has a unique branching model. Git allows and encourages you to have multiple local branches that can be entirely independent of each other. How many have used Git? Yeah. Okay, we'll see. So, what do I mean when I'm talking about branching model or branching them? Can anybody explain that?
Or you bring you bring yourself a separate repo for yourself to work on without interfering with others' workflows.
Yeah.
Or when you want a new feature, you might branch.
Yeah.
So you can just work on that feature and eventually merge it with the main branch.
Yeah. So that means that you can have several version histories in the same repo. You see? Typically we work on a master branch, you know, and we do some coding, and we stage some of the changes that we have done, and we commit them. That means that we are more or less marking a new node in the history tree of our repo. So, but when we're branching out, we're going from, for example, the master branch or any other branch, we're using the same version history as we had in the branch that we're branching out from, and we continue on that history, but the new history is separate from the master branch history. So that's the thing about branching, and it's quite convenient, of course, because then we can work on new features without interfering with whatever is on the master branch or any other feature branch that any other developer works on. So this gives us frictionless context switching. What do I mean by that? Let's say that I'm working on this feature, and I'm on my feature branch. So I branched out to a feature branch. That means that I have a context for the software there, you know. So I have my version. Maybe I can serve it on my computer, on my local computer, and I'm working on that version. Okay. But as soon as I get a call from my supervisor or something, he says that, okay, you have to do some hot fixing on the master branch, on the product that we have in production. You have to do a hot fix, okay? Then I can switch my context back to the master branch. I can branch out to maybe hotfix branch, where I do this little bug fix that have occurred in our code, and merge back to the master branch, and we have a new production release. And that means that I can switch contexts between production releases, between developing my developing branches, and so on and so on. It's quite frictionless. We can have role-based code lines, feature-based workflow, and disposable experimentation. The last one is typically when we do something on a feature branch or a branch that is quite experimental. We can see that, okay, this is not working, we're just throwing it away. And it doesn't affect the history of the product itself in any way. Yes, terminology. Repository. You can say that's kind of the project's folder. We set up a Git repository on our local computer, then you have typically that folder as the context of the project. We have a branch that's a parallel version or an own version history of the repository. We have a remote. That's the version of something hosted on a server. Local clones are connected to the remote. They aren't always, but typically you connect them to the remote so that you can send your changes to the record on the server. That means pushing your changes. So we call Git repos on servers that we communicate with remotes. And you can have a clone, that's a copy of a repository connected to the remote version, and so on. A commit, that's a revision and an individual change. The typical workflow when we do a commit, that means that we commit the code that we have to the history. The typical workflow that we have is that the first stage changes before we commit them. And what does that mean? That means that we say that this, and this file should be a part of next commit. Then we stage changes. Okay? So we have changed a lot of code in these 3 files. So we stage them. How do you do that in Git? Stage a change. Git, command line, Git add, for example. Git add a file, then you stage change. And then, if you want it to be a part of the version history, we commit it by git commit. So that's the typical workflow of one commit, one version history node. We have diff, that's the difference between 2 commits. Typically we work with commits, diffs, whenever we're maybe reviewing the changes that some other developer has done. Then we can look at the diff between one commit and another and see what have been changed. Fetch, get the latest change from a remote repository. Merge changes from one branch applied into another. And pull, fetching changes and merging them. That means fetching them from the remote and merging them to your local repository. And we call something in the upstream, that's the primary branch. Okay, distributed Git systems. There are a lot of Git systems out there that give you some administration GUI so that you can administrate your repos. For example, GitHub and Bitbucket are probably the 2 largest. Do you use any other administration systems for Git? No? GitLab. Who's using GitHub? Bitbucket? Yes. Bitbucket integrates nicely with the Jira and Confluence. So that's a good alternative if you're already married to Atlassian. That's a good alternative. But you could also set up GitHub to integrate with Atlassian software as well. Yes, Git basics. Sorry. Yeah, great. Wait a minute, and I'll be back where we were. There we are. Do you use the command line or do you use the GUI for?
I use a GUI.
GUI. Sorry. Yeah. The GUI are. What kind of GUIs do you use then? Source tree. I haven't used source tree yet, but I suppose that's popular.
Yeah, no, it's not used.
Okay, I see. Yeah. No, I use the command line almost all the time. And that will be what I'm going to show you as well, the command line. So if you're not familiar with using the command line with Git, then this will be a little introduction to that. Okay? So let's pull up the command line here as we go along. Let's close this. This is from... Okay, I'm starting a new project now. Let's see, I have a test folder here. Can you see this? Maybe a little larger? Now you can see it. Okay? Yeah. So what I do, I make a dir directory with git basics. And then to start a new project. Let's say I have some code here already. If I do something like this. Sorry. Yes, now I have a file called test.txt with the text hello world. Okay. To start a new Git repo here. Well, what do I do? Yes, git init. Initialize empty Git repository in user status. And what happens then? Let's look at Sublime, for example. I still have my text.txt here, and I should have a Git folder here. You see? And that's where Git holds all of its metadata about the version history and so on. For example, it holds a config file where you can set up a lot of config stuff related to Git. Okay, now I have my file open here. I want to do an initial commit. What do I do? What do I do now? Yeah, first I need to stage the file. Either I do git add and the name of the file, what did I call it? Test.txt. Or maybe git add, if I know that I want to add all the files that have been added to the repo, I'd use -A. Now it says that I have a new file, it's staged. If I now create another file, and I write git status, I see that I have one untracked file that's not staged for any commit or anything, and I have one file, new file, which is called text.txt that is staged for a commit. But staging doesn't mean that I have done anything with my version history. I can say git log here, and I have no commits yet. There's no version history here. Then I need to commit the changes that I've done. And typically I also pass a message, a commit message. Okay, let's see the log now. Now I have one commit here, the initial commit, and it gets some hash. That's the identity of this commit. You see? Yeah. Git init. So I start a new project by git init, do my first commit by staging the first file I've written, or the first 10 files I've written. Git add, and I committed those changes with git commit. You find all these commands in your Git GUIs as well, with the same names, so it's the same principles. Okay, git clone. What do I do when I do git clone and provide some URL of some kind?
You copy that repo.
Yeah. Typically Git copies that repo and set up a reference to that repo so that you can push and pull to and from as well. Yes. So this is a clone from a GitHub repo. Okay, git add. We talked about that. That's for staging files. And git commit with a commit message. That's to create a new version history node. Okay, let's look at git flow then. That's one branching mode, one of many different branching modes. Git flow was formalized by a guy called Vincent Reason that works for NVIE. It was more or less an effort to formalize how you do branching in your Git repos, so that's standardized more or less. This is not a standard. This is Vincent Reason's standard. So it's standardized for his company. But many have adopted this kind of branching. Let's look into it. To install it, you can go to github.com NVI git flow, and you will find a repo. And you have a git flow cheat sheet as well to find the commands that you can use in Git flow. But the most interesting thing is the branching model. The thing here is that you start with the master branch, and that's where you keep all your production releases. And what you can do is in Git, you can tag some commits and say that this commit has this keyword, for example, like 0.1 or 0.2 or 1.0. In this example, or in Vincent Reason's Git flow model, is using it for the version numbers, and that's quite ordinary. That's how tags are used a lot of times in Git branching modes. The main thing here with Git flow is that you have a master branch, and you separate any development into a develop branch. So you have the entire history of your develop branch here, and whenever you want to release something, that means put it into the master branch, you start a release branch from the develop branch. Here you start a release branch, for 1.0, and maybe you do some bug fixes whenever you're starting a release branch. Maybe you have a release candidate as well that you provide to users or something like that, and you do some bug fixes during the development, maybe some new minor changes as well. And then whenever you feel that this is production ready, okay, we have tested it through and through with users, with the tests that we have implemented, and we are okay to make a new production release, okay, then we merge it back to the master branch, and we tag it with 1.0, and then we have a new release. Okay, the same thing goes for feature branches, but every feature branch is branched out from the develop branch. So you work from the develop branch at any time. Feature branches are merged out and branched out and merged in if they are maybe if the development team means that it's ready to be brought back to the development branch, it's merged back. And if you have bugs in your production releases, you branch out to hotfix branches to fix those bugs. Okay? For example, in tag in version 0.1, we had an error there. So we need to branch out to hotfix branch and merge back to master as soon as that hotfix is done and ready and tested. And hotfixes are also merged back to the develop branch, so that the develop branch always keeps up track with the master branch. So this is one branching model. Git flow also gives you a command line or a command line built over Git, so that you have Git flow commands with your Git commands. So Git flow start Git flow init. Then you start a Git flow repo. It's still a Git repo, but the commands that the Git flow have implemented is just an built over Git flow, so it doesn't affect Git in any way. You can use Git as normal. It asks me what's branch name for production releases. I use default master, and for develop is the default feature, and release and hotfix and support branches. And then I can start branching out with Git flow start feature hello. Git flow feature start hello. That's the right way. Now you see that I'm in the feature hello branch instead of the develop branch. And this command line tool from Git flow is quite useful to branch out the correct way. It does the small things in Git for you, like Git branch and naming the branch consistently and so on. But that's one branching model. I see that I will have little time for quality assurance today. So we'll see if I provide you with a video instead. There are other Git workflows as well. You have the centralized workflow. I have this resource from Atlassian where they describe these types of workflow. Centralized workflow, where you typically have always have your repository remotely, and you work based on that all the time, and all the developers push and pull back and forth from that repo. Feature branch workflow. That's quite similar to feature branching in Git flow, where you feature all your features are branched out in feature branches. But whenever you want to merge something back to the master branch, you do a pull request. You can do pull requests in, for example, Bitbucket and GitHub, and that means a request to those that maintains the repo to review the code that you have done and merge it back in Bitbucket, for example, merge it back there to the master branch. Sorry? Yeah, good question.
Probably because you need to have approval to it can actually be pulled into the repo.
Yeah, but I see the point because it's actually pushed into the repo.
Yeah, I agree.
So I can't answer that, sorry. But you can look it up and find the answer for next session, okay? And you have the Git flow workflow. It's quite similar to fork and PR. And it's quite often used in many open source projects, I've seen. The main thing is that you have a repo on GitHub, for example. You have a repo, and you fork that out. You know what forking is? It's not like cloning, it's quite similar. But there you do a full copy of the repo. You don't set it up in a reference to the actual repo itself. So that's a full copy of the repo. You continue working on that copy of the repo, and then you do a bug fix or you do a feature or something to maybe an open source project. You do a pull request to those maintaining the project, and they check if this is something that they can use or this hotfix is nice. Okay, then they approve the pull request and merges it back to the original repo. So that's fork and PR. In my company, I've used Git flow workflow and fork and PR. Sorry, Git flow workflow and the feature branch workflow. PRing on the repo, that's quite neat. And Git flow is quite neat as well. So that's my experiences from these types of workflows. So you have to find out with your project teammates what kind of branching workflow you want to use in your project. Okay, some resources and references to Git, Git tutorials. and GitHub help. And if you want to read up on comparing workflows to evaluate what you want to do in your team, you can look at comparing workflows from that. Yes. I was supposed to do quality assurance as well today, but I see that there's no time for that. We used a little bit too much time on different things today. I will give you a link to a recording I did last year on the same topic. It's quite similar to what I was supposed to do this year. So you can look at that. Yeah. Okay. Any questions to Git and version control systems? No? If you have any questions, don't hesitate to ask both me or your supervisor or your product owner, because they are also familiar with these tools. Yes. Yeah. So that's it. We'll meet again in 2 weeks, I think. Yeah.